Good morning, everybody. It's a real privilege to be involved in this webinar that will explore equitable agriculture and food systems. As you can see from my title, I'll talk about nutrition, global health, and inequalities. This figure from the latest Intergovernmental Panel on Climate Change special report, which focused on climate change and land, shows a food system, and it shows the various interactions across various drivers and outcomes of a food system. It shows you how complicated our food systems are and shows that although I'm going to be focusing on food security and its consequences for human health and well-being, that there's other factors as well, that inequalities are built into our food system in terms of who farms, who owns the land, and what the consequences of food systems are for socioeconomic benefits, and who experiences the highest level of food insecurity. Mostly it's the poor and marginalized that suffer the highest levels of food insecurity, and I'll talk about that a little bit more throughout my talk. This figure from the Food and Agriculture Organization shows the pathways between uncertain access to food at the individual or the household level through to three forms of malnutrition. One is child stunting and wasting, also called hunger, also called undernutrition. There are also a large number of people, more people than are stunted and wasted, who have micronutrient deficiencies. And the third category is overweight and obesity. So when you think of malnutrition, you need to think about over and undernutrition. These three categories of malnutrition are not independent. This figure shows you the intersection between obesity and overweight, both in children and adults, stunting, wasting, and micronutrient deficiencies in the form of anemia in women. And so you can see that these co-occur in many situations. As you look at these countries, you can see that many most affected are low and middle income countries. And within those countries, again, it's the poor and the marginalized who are the most affected. Our diet matters to our health. This study that was cited in the IPCC Special Report on Climate Change and Land focuses on three diets that are supposed to be healthier for us. The Mediterranean diet, a diet that focuses more on fish, and a vegetarian diet. These bars show you the reduction in the relative risk. So it should be shown going downwards, that you have less risk, the higher the bar is. The expectation from what you read in the media is that a vegetarian diet is healthiest. But in fact, when you look across the data, you can see a vegetarian diet is indeed healthiest in terms of reducing the risk of type 2 diabetes. But it's not that much different from the other diets for cancer, although for cancer you see the Mediterranean diet has the lowest risk, for coronary mortality, and for all-cause mortality, again, the Mediterranean diet looks like it's better in terms of our health. All of these diets, though, are important from a climate change perspective because each of these diets reduce greenhouse gas emissions, and agriculture is a major contributor to greenhouse gas emissions. Why are we talking about food security in terms of a changing climate? We're doing that because when you look across the studies, this was published again by the Intergovernmental Panel on Climate Change, this focuses on wheat, but there's similar results for several of the other cereal crops. And you can see in temperate regions that a local mean temperature change under two assumptions of adaptation really doesn't affect wheat yields very much. Under one assumption, wheat yields go up, and one it goes down a little bit, but very little change in wheat yields. On the right, in the tropics, you can see that any increase in local temperature results in a decrease in yields. Most of our cereal crops that are important for our health are being grown in the tropics very close to their thermal tolerance. So all of the projections of what could happen with climate change, whether you assume low or high greenhouse gas emissions, looking either shorter term in 2030 or towards the end of the century in 2080, show a very sharp reduction in crop yields. And that's because of the challenge that we're seeing in the tropical regions with these crops. That reduction in crop yields directly leads to an increase in stunting. And you can see data from the World Bank for 2030 and 2050, the increase in severe and in moderate stunting under a range of different assumptions. And it's not just climate change. I'd like to step back for a bit and talk just about carbon dioxide itself. Our plants, through the process of photosynthesis, remove the carbon from carbon dioxide and incorporate it into organic molecules. There's three basic pathways by which plants do this. 85% of all of our plants, including wheat, rice, barley, potatoes, trees, grasses, use a pathway that's called a C3 pathway, and these are then called C3 plants. A different pathway is 3% of our plants, and that's corn or maize, sugarcane, millet, sorghum, and pineapple. And they have a very different pathway that takes the carbon out of the carbon dioxide. And then the third pathway only occurs in succulents. There's been experiments with carbon dioxide out in the field, where you have a large field, you break it up into plots, you blow carbon dioxide across some of these plots to see what happens. And looking at the C3 crops, you see a significant consequence. First of all, I'm sure you've read in the media that carbon dioxide is plant food. And indeed, under higher CO2 concentrations, the C3 crops grow faster. They also have less protein and less micronutrients. Over the studies that have been done, there's about a 10% reduction in protein, about a 5% reduction in micronutrients, and about a 30% reduction in the B vitamins. This is important because right now in the world there's about 830 million people who are food insecure. About 830 million people sometimes go to bed hungry. There's about 2 billion people who've got micronutrient deficiencies. There's over 1.5 billion women and girls who've got iron deficiency anemia. Many more are on the edge, which means for many parts of the world where 75% of the calories come from starches, that having less protein and less micronutrients could have significant consequences for health and well-being. At the same time, because plants grow faster and plants then have more carbon in them, they have more carbohydrates. So the starchier plants become starchier. When you put this together, this contributes to what's called the hidden hunger when you have micronutrient deficiencies. A study published last year looked at the global availability of dietary protein, iron, and zinc, combining the consequences of a changing climate and of higher CO2 concentrations. So looking in 2050, the modeling took into account positive influences of technology change, market responses, and the CO2 fertilization I mentioned, and the negative influences of climate change on productivity and this penalty on carbon content of what the increasing carbon content means for nutrient content. And you can see at the bottom, when you put these factors together, that protein growth is decreased by about 20%, iron and zinc by almost 15%. When you look at this graphically, you see this figure by major regions in the world. And when you look at these figures, it's protein and then iron and then zinc. The red is the carbon nutrient penalty. And that's remarkably consistent around the world, as you would expect, because carbon dioxide acts the same everywhere. The blue has to do with technology change and CO2 fertilization. And so you can see that the responses vary quite significantly around the world, with some places seeing a much higher change from technology change and market responses, and some seeing very little. The assumptions in the study were fairly optimistic, which is why you see sub-Saharan Africa and South Asia benefiting, in addition to East Asia and Pacific, in particular from these positive influences. But then overall, even with these positive influences, this carbon nutrient penalty is going to take away from that. The estimates range across the studies in terms of what the consequences are. When you look only at rice, and you look only at the poorest rice-dependent countries, the estimate is by later in the century that 600 million people could be affected. Some of the other studies come up with slightly lower numbers than that, but all of the studies are in the hundreds of millions of people that could be affected. And again, these are the poorest and the marginalized in all countries. When you think about our own country and think about how many people who are poor rely heavily on starch, particularly in our country on wheat and sometimes on rice, and what the consequences of an even poorer diet with more starch in it could be for their health and well-being. So where is the highest risk? When you look at the combination of these factors and you map them out, you can see that the highest risks are in parts of Africa and very much in parts of Asia. There also could be risks, as I mentioned, in our own country, but the risks will be focused on those who already are suffering from the highest rates of undernutrition. And those aren't the only consequences that could happen with higher CO2. So you can see a range of points on the slide. You can see altered plant allocation of carbon that happens under higher CO2, changes access to nutrients and contaminants in the soil. And so you could see higher cadmium and methylmercury in crops such as wheat and rice. Experiments show that higher soil temperatures increase arsenic uptake in rice, so another contaminant into our food supply. These changing carbon-nitrogen ratios affect other compounds in the plant. An example is the chemical that is found in a plant in primarily China that is widely used to treat for the most severest form of malaria, has increased significantly. It's because that particular molecule has more carbon and no nitrogen in it. And it's not just humans. There are studies that are coming out showing that the change in grasses, which are also C3, are changing then what our livestock can eat. And they're becoming increasingly protein stressed, which is decreasing their weight because of the reductions in nitrogen availability in the grasslands. And this is just the start of a research agenda. There's a huge amount of work that needs to be done in this area to better understand the magnitude and possible pattern of consequences and to see what can be done. Generally, we know there are a range of things that need to be done. We need to improve governance and leadership, secure food entitlement for all. We need to pursue and encourage technology breakthroughs, water quality, water quantity, more investments in sustainable agriculture. There's work that needs to be done to address food demand and food supply. And we need to improve our modeling so that we can better inform policies to ensure that they are taking the most effective and most efficient actions. And finally, when you think about food security, think about the children. 85% of the health risks of a changing climate are in children under the age of 5. So we need to make sure that we do take action to protect those who can't protect themselves and help ensure that they have a sustainable future. Thank you.